Hi everyone, my name is Genevieve Davis from the Northeast Fisheries Science Center. Today I'll be speaking about a few of our passive acoustic monitoring projects from our acoustics group. I'd like to first acknowledge my co-authors Nicole, Molly, and Sophie, who are involved in the primary syntheses of these projects, but recognize that for each of these projects there are many collaborators involved, and those folks will be listed accordingly with each project. The first project is our Passive Acoustics Cetacean Map, or PACM. We've presented on previous developments of this project, which was originally created for us by Hanson Johnson based off of his whale map. The current website was developed by Jeff Walker, and it is now live on the website, which is listed above, and I'll have on the next few slides as well. The goal was to have an interactive website that allows for exploration of all publicly available passive acoustic detection datasets in one place. This includes detections for both baleen whales and odontocetes, as well as detections from any recording platform such as bottom-mounted recorders, gliders, or towed arrays, all displayed together. It is meant to be updated routinely so that the most recent detections are available and is a way to look at analyses conducted by various groups or for different projects, all to be together in one spot. Anyone is invited to contribute their detection data using data templates we've created, which I'll explain more on future slides. We plan on expanding this page eventually to include additional species and have automatic real-time updates as the data is submitted or available, such as from Mark Baumgartner's Robots for Whales website. To quickly highlight what the site brings you, when you first visit the site, the About, User Guide, and Tour window pops up, which includes a guided tour to navigate through the page, as well as video tutorials and text information to understand and better interpret what you're looking at. You can then click on these buttons anytime after to revisit them. Next, you can select which species detections you want to look at here. You can filter the type of recording platforms for which the detections are from. You can select the start and end dates of the season by sliding the start and end buttons accordingly. You can filter the years over which you want to look at here. And you can filter whether you want to look at only recorders that had detections or any other possible conditions listed here. The legend shows you how many recorded days and recorders you are viewing based on your filtering from the left. You can click Normalize by Effort button, which divides the number of days with detections by the total number of recording days for that recorder and adjusts the size of the points accordingly. Lastly, you can draw a box or boxes of areas of interest that you can then further filter using the left panel. When you hover over a recorder of interest, a metadata box pops up on the map, and if you click on the point, a chart pops up on the bottom, which provides the metadata information again, as well as a time series for that recorder that shows when right whales were detected, possibly detected, or not detected. If multiple recorders were deployed in this location, you can cycle through them by clicking on the arrows next to selected deployments at the top of this box. We've created templates to submit detection data and the metadata associated for those recorders, as well as GPS data templates in the case of mobile platforms. These templates follow ISO standard formatting and are compatible with NOAA's NCEI archives, which are currently what store a lot of our larger passive acoustic monitoring data projects. For more information or to access the templates, please visit our Passive Acoustics webpage, which you can find simply by Googling NOAA NEFSC Passive Acoustic Research. Currently, with our collaborators listed, we have 14 sound trap recorders in the water that have been analyzed for right whale occurrence for 2020. These maps show recording locations for the year 2020, split into the first and second half of the year, with January through June results on the left and July through December results on the right. The red points show locations of recorders that had at least 1 day of right whale detection during that 6 months, and the black points show recording locations that had no right whale detections during that 6-month period. Of the 8 recorders deployed along Maine's coast, there were a handful of right whale detections at the York, Monhegan, and Lubec sites. Lubec had 1 day with right whale detections in June and 1 day with right whale detections in October. Monhegan had 1 day of right whale detections in December, and York had 1 day of right whale detections in November. The Stellwagen Bank National Marine Sanctuary buoys, which are the sites starting with SB, had right whale detections on all 3 sites, with most occurrence happening across all 3 sites from January through April. There were 2 days of right whale occurrence in July, 1 day of right whale occurrence in August, and 1 day of right whale occurrence in October. For the Nantucket Shoals buoys, which are the sites starting with NS, there was at least 1 day of right whale detections on one site for every month, with most of the detections occurring more consistently from January through April. All of the recorders shown here have continued recording effort through 2021 and with plans to continue that monitoring effort, with additional sites planned or already in the water for 2021 and 2022. As a start, there are 2 recorders deployed on Cox's Ledge, which have started in 2021. And of course, all of these detections and recording locations can be viewed in more detail on our PACM website. We've created 6-month summary reports for the Northeast recorders that have been analyzed for right whales. Here's a snapshot example of what they look like, where the map from the previous slide is shown, as well as a table listing the number of days with detections over the total number of recording days for each month by site. These reports do not give the specific dates in which right whales are detected, and they only include data that have been analyzed at the time of the report's generation. Our goal is to send these out every 6 months, if possible, to interested parties. But again, all of the information generated on these reports is also available at PACM. If you are interested in being added to the distribution list, please email me. Together, NOAA and BOEM have been working on projects involving offshore wind development with a goal to have cohesive PAM effort in place for both baseline information and mitigation efforts. This past summer in 2021, BOEM hosted a workshop on regional passive acoustic monitoring to get all parties of offshore wind energy development involved in a discussion. There were about 45 participants from 30 organizations comprising of federal and state government, industry, and academia. This workshop was aimed at regional monitoring, and from this came the proposed grid here as a way to monitor within and between planned wind lease areas along the coast. There will be a second workshop in the fall to further discuss archiving, storing, and reporting on the acoustic data that is collected and analyzed. The written summary of the report will be available soon on BOEM's website. These grid proposals were designed with the purpose of having full coverage along the coastline for both baseline and mitigation purposes. The grid spacing is specifically geared for full monitoring coverage of right whales, with 20-kilometer grid cells within lease energy areas based off of a right whale's average detection range of 10 kilometers. The grid incorporates coverage between lease areas by expanding to a 40-kilometer grid cell in an effort to make this type of design reasonable and manageable. Each grid cell has a letter and number for reference, and it hopes to easily identify where any party is monitoring and where still needs to be monitored. Shapefiles for these grid cells can be downloaded through the Northeast and Mid-Atlantic Ocean Data Portal and are there to help create a unified PAM effort across the East Coast. Here's what the layers look like for the grid cells on the Ocean Data Portal, which you can navigate to under Marine Mammals and Sea Turtles, and then under the proposed passive acoustic network layers on the left. Each of the grid cells can be clicked on where the proposed monitoring stations are the dots in the center of the cell, which brings up a metadata box with a latitude and longitude location for the point, as well as the grid cell ID. Also on this page is a layer where you can view which grid cells have had North Atlantic right whale detections since 2010, which are the cells highlighted in red here, and which grid cells were monitored for at least a few days but had no detections, which are the cells highlighted in blue here. These detections are based off of what you will also see in PACM, so you can go there for more details. Lastly, there is a layer where you can view what grid cells currently have recording effort. The goal of this is to be able to have an easy way to view and determine where to put recorders out so as not to duplicate efforts and to maximize acoustic coverage along the grid. Much of the information discussed in this workshop is in the Van Paris et al. Manuscript that is currently in press with Frontiers in Marine Science. The manuscript gives recommendations on all topics of PAM, from recording equipment to study design to analysis and data archiving. There are supplementals in the manuscript that are specific to monitoring for right whales, as well as supplementals that include information on all of these proposed PAM grid cells shown on the previous slides. The manuscript encourages the submission of detections and reporting to PACM, which again is live, and we welcome you to explore it. With that, thanks so much to all the many folks involved in all of these projects. Thank you for listening, and I look forward to answering any questions during the meeting.